This is section 2.1, represent relations and functions. Now there's a little vocabulary that goes along with this section. First of all, a relation is anything that pairs inputs and outputs together. Now, most often in algebra, the inputs are called the x's and the outputs are called the y's. And so there are several ways to pair x's and y's together, and we'll look at those in this section. Speaking of the inputs, we have something called the domain of a function or a relation. The domain is the list of possible inputs in a problem. In other words, what are the possible values that we can put into the problem for x, for the variable that represents x? The range is similar, except that's the list of possible outputs. So when I put numbers in for x in the problem, what could the answers possibly look like? Are there any restrictions on what the answers might look like, and so forth? So that's what the range would be. Now a function is a special kind of relation. A function pairs x's and y's, or inputs and outputs, so that each input, or x, has only one, and that's so important, only one output that goes with it. So anytime I put a number in for x, I only get one answer. As long as that's the case, then it's a function. And finally, an equation in two variables that just simply means that you have two variables. You have an x and a y. You have an input and an output variable in each case. All right, so let's take a look here. Oh, linear function. Finally here, a linear function is one that looks like y equals mx plus b when you get the y by itself. Another way to describe that is that the graph is a line. So those are some definitions of a linear function. So representing relations. Well, there's basically several ways that you can represent a relation. I can think of 5. The first one might be a set of ordered pairs. So a set of ordered pairs is a way of taking an x and pairing it with a y. Secondly, you might have a table. Okay, we have our x values and we have our y values. It's basically the ordered pairs only organized in a table. Thirdly, we have a graph. Now, with a graph, we have our x-axis and we have our y-axis, and each point that's on this graph represents an ordered pair. So it shows us an input and an output paired together. Fourth, a mapping diagram. With a mapping diagram, we list the inputs, or the values in the domain, and we list the outputs, or the values in the range. And then we use an arrow to go from the element in the domain to the element in the range that pairs with it. So a mapping diagram is another way of showing a relation. And then the fifth way, I'm going to put this over here in the margin. The fifth way is with an equation. An equation will map x's and y's together, such as, for example, y equals 3x plus 2. If you put a number in for x, it'll tell you what the y is that goes with it once you figure out the math. So an equation is another way to show a relation. Let's take a look at example 1. It says, tell whether each relation is a function. Well, remember that to be a function, each value of the input, or each x, can only have one y that goes with it. So when I look at letter A here, I have an x value of -2, and it's paired with -1 and nothing else. When x is -1, it's paired with 0 and nothing else. When x is 3, it's paired with 0 also, but that's okay because this value of x is only paired with one number. And this 6 here is only paired with 4. So I would say this relation is a function because each input is mapped onto only one output. On the other hand, when you look at letter B, look at down here this x value of 2. It's being paired with 2 for a y, but it's also being paired with a 3. So an input of 2 has two different numbers that go with it. And so therefore this relation is not a function because the input 2 is mapped onto both 2 and 3 at the same time. Now, an easy way to do this with a mapping diagram is to think of the input over here as being an archer and the output being the target. So this guy shoots only one arrow. This guy shoots only one arrow. This guy shoots only one arrow. Now, these two are shooting at the same target, but that's fine. And this guy is only shooting one arrow. In part B, though, this person right here is shooting 2 arrows, and so therefore that's not a function. So each input can only have one arrow coming from it in order for it to be a function. So that's an easy way to maybe remember for some people. All right, moving on here. In order to determine if a graph is a function or not, okay, a graph is a relation. However, sometimes it's a function and sometimes it isn't. So a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. Now, in a nutshell, what that means is you can't have any points on the graph that line up in a vertical line. When I look at letter A right here, this picture shows us a kind of a U shape, although as it goes to the right, it's continuing to spread out, and same to the left. If you take any 2 points on this graph, those 2 points will not line up in a vertical line. So we would say that this one is a function. Over here in the second one, however, if I look at this point on the graph and this point on the graph, they do line up in a vertical line, which means for an x value of 2, there are 2 different y's that go with it. So that's not a function in that case. So that's called the vertical line test. As long as a vertical line only hits the graph once, it's a function. But if it hits the graph more than once, it's not. So let's take a look at example 2. We're going to use the vertical line test to determine if this is a function or not. In letter A, we have these points here that show our relation. Do any of those points line up in a vertical line? The answer is no, they don't. So therefore, this one does represent a function because no vertical line intersects the graph at more than one point. The second one, however, if you take this point and this point, they line up in a vertical line. So does this one and this one, but it only has to happen once. Okay? So we would say that this graph does not represent a function because the vertical line at x equals 3, that's the line x equals 3, and the vertical line at x equals 6, but again, it only has to happen once. The vertical line passes through more than one point in each case. So letter B is not a function. Okay. Now, graphing an equation in 2 variables. When we have 2 variables, an x and a y both, we can graph this equation. One way to graph this equation is by constructing a table. So we construct a table of ordered pairs. Then we plot enough points from the table to recognize a line. Then we connect the points with a line or a curve. I'm sorry, this should say pattern. because it isn't necessarily always going to be a line. So linear equations, yes, but not all equations are linear. So we plot enough points to recognize a pattern, and then we connect those points either with a line or a curve. Now in this chapter, though, right now we're focusing on linear, so it's going to be a line. So let's look at example 3. In example 3 here, we want to graph this equation. So we begin by making a table. Now, when I make a table, the first thing I want to think about is the domain of this equation. The domain would be the values that I'm allowed to use for x. Since x is going to be multiplied by -2, I could probably use any real number I want to for x. There aren't any restrictions there. However, I'm going to want to use numbers for x that are going to be easy to graph. So when I look at my grid over here, my x's go 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. I want to pick x's that will fit on there. And we don't want to do too many, but it's a good idea to do at least 5 points. I would suggest that we use -2, -1, 0, 1, and 2. And so those are the ones that's being used in the table here. But it is important to realize you could use any real number you wanted to. It's just that these make it easier to graph it. So let's start with -2. So I'm going to put -2 in over here for x. So -2 times -2 is 4. And then when I take away 2, I get +2 for y. Then we're going to do -1. -1 times -2 is +2. And then when you minus 2 from that, you get 0. Plug in 0 for x. -2 times 0 is 0. Minus 2 is -2. Put in 1 for x. You're going to get -2 minus 2, that's -4. Put in 2 for x. -2 times 2 is -4. And then when you minus 2, you get -6. So those are the ordered pairs for my table. Now I want to plot those points. So I'm going to go to the point -2 comma +2, -1 comma 0, 0 comma -2, 1 comma -4, and then 2 comma -6. Now notice that these points all lie in a line. So I'm going to go ahead and connect those points with a straight line. And so connect the points with a line. So there's the graph of that equation. Now the last thing we want to do in this section is try to determine whether or not we have a linear function. And so as I look at these problems, we want to try to make that decision. Now remember, to be a linear function, it has to be able to look like y equals mx plus b. Now in letter A and letter B, notice the notation here. That notation, that f and then an x in parentheses, we say f of x. That's how we read that. And the g and the x there in parentheses, that's g of x. Now f of x and g of x, each one of those is called function notation, but that's just another name for the y in the problem. So when it's a function, when the relation is a function, we use function notation to do that with. So let's look at letter A. Does this look like y equals mx plus b? Sure it does. So I'm going to say that the function here is linear because it looks like f of x equals mx plus b. Now I'm supposed to find y when x is -3. So what I want to do is I want to find f of -3. And it looks like this. And so what we do is we replace the x with -3 in the notation. And what that tells me to do also is to put the -3 in for the x on the other side. So 6 times -3, that's -18 plus 10, that's -8. So we substituted the -3 for the x. Now in the next part, it asks us if we have a linear function. The answer would be no, because of the x squared term. And I'm out of time, so that's going to be the end of this section. Don't forget to put -3 in for the x in the function in order to evaluate that and figure out your answer.